move that over. Is that any better? Yeah, cool. All right. Cool, cool. So I am sending that out now. And that should be good to go. All right. So good evening, everyone. We are here for another virtual event with the OWASP NoVa team. I have Dan from Secure Warriors, who's gracious enough to help present. Thank you, Dwayne. Gracious enough to help us have this CTF event. The Slack channel is open. I'm going to post the invite link in there very, very shortly. The code has been sent out, but that number is 12535854. So feel free to take it away. Just one little housekeeping note. We're going to have another virtual meetup in about 2 weeks. And good luck. So Dan, if you want to get us introduced.
Yep, I appreciate it. Thank you so much. I'm just going to share my screen here. Give me 1 second. Okay. Here we go. All right. Can you see my screen?
Yeah, I can see just fine.
Okay, great. Thanks, everybody. I really appreciate the opportunity to join your OWASP chapter tonight. And we're going to do something really fun tonight. It's a secure coding tournament. My name is Dan Lewin. I'm an account executive here with Secure Warrior. Been with the organization for over 2 years now. And who is Secure Warrior? We're a global application security firm. We've been around for over 5 years. And really what our vision is to really empower developers to become the first line of defense in the organization by making security highly visible and really providing them with the skills and the tools so they can go about writing secure code from the very beginning. What we did, our founders created a cloud-based platform, and where we think it's the smartest and easiest way to help improve an application security program, because we're allowing developers secure their code from the start. And what ultimately that does, it really benefits the organization. It helps them achieve faster, more secure product development. It will provide or bring in more developers that become more security conscious, able to defend their own applications. And I think one of the key pieces of how our platform could really benefit an organization, it really builds out a positive security culture. So those are 3 things. And really what we're doing, we're changing the paradigm from traditional to a more hands-on approach. Traditional approach has been around e-learning and classroom instruction. This is very passive teaching methods, and these are great when it comes to concepts, but it's usually a point in time when it comes to training. But something that is trained 1 month and 3, 4, 5, 6 months down the road, that person may lose the knowledge retention around that. So what we find is a lower knowledge retention rate over time. Whereas Secure Warrior, we provide a more hands-on, practice by doing approach. So think of something like working with your hands. This can really come benefit to learn something, and then you can retain this knowledge for a longer period of time. Where we fit in the software security development lifecycle in the SDLC, we actually we don't shift left, but we start left. We're in the prevent stage, and we're not here to replace existing vulnerability testing tools out there. There's a lot of great tools out there, and and it's best to continue using those. But again, we are here to enable developers to make them better secure code developers, and we start from the very beginning, and in doing so, we want to limit the number of vulnerabilities that go into your software. So at the end of the day, the cost of fixing a security bug will start to go down. As I mentioned, we are a cloud-based platform. We have a number of unique features that are built into the platform. With access to the platform today, you have access to the learning and the training. These are specific training resources of videos on specific types of vulnerabilities. We also have the training, which is you're going to spend the bulk of it, where you're going to help build and maintain skills. And that's really self-paced, scalable learning. It's going to cover multiple languages and frameworks. It covers things such as the OWASP top 10, as well as other top security vulnerabilities. And we have over 35 different languages that are in the platform, with over 4,500 challenges. So quite a bit of language and content. This covers everything from web-based, mobile, infrastructure as a code. We even got some C, C++, even COBOL, some mainframe that's in our platform today. So really covering a lot of the gamut out there. So you can take some of this training, practice, prepare for the tournament. You go in the tournament. We have 20 languages tonight we'll go over that you can choose from. You can only select one language to compete. But tournaments is a big piece of our platform. It's going to help, it helps change the culture and the culture shift and the awareness around the organization. Makes it fun. It's something, you're learning, but at the same time, it's making something that's really fun and entertaining. So I hope you enjoy. Just going to show you an example real quick, what it looks like in a challenge. So when you go into our platform and then you go into the training, you're going to be tasked a couple of ways. So you're going to be tasked to locate, identify, or fix a particular vulnerability in the language or framework that you're working in today. In this particular example, I'm actually working through JSP. And my vulnerability category I have here is around injection flaws, and I'm focusing on an SQL injection. So I'm tasked here to identify one vulnerable block of source code from over here. You may have some more difficult challenges where they may ask to find 2 or 3 vulnerable blocks of source code. But in this particular case, we can go through this entire code tree, and we can basically identify which one we think is the best to highlight. Once you figure out this is the block of code, you would click on the little yellow triangles, and if that is the vulnerable piece of code, you would hit next to see if you got the answer right or wrong. But what I highly recommend your first time going around is to use the hint button. And this is what the practice by doing is you're learning along the way. The first hint is free. There's no points taken off. Typically, it's going to talk about what is the vulnerability about. There's going to be a video, a short video that's going to accompany it. It's going to be part of it, so you can review that in your own time. But it's just another way to kind of help you identify or locate that particular vulnerability. You can go back, close it off, and continue to move through the exercise. If you need more help, you can use more hints. The hints will help you identify the answer. The challenge is you will start getting points taken off. And the idea of the game is to score as many points as possible. So the first hint is free, but I highly recommend using that for the first hint, but after that, try to figure out and solve the problem. So just wanted to kind of show you what a typical problem is. You're going to be going into the tournament here. As you can see, you can enter the play. You're going to see something like this. The screen the first time is going to be a little walkthrough. Hit accept, and then you're on your way into playing. So I don't want to take too much time here because I know everybody wants to get into the actual tournament, but just some tournament details. We do have 20 different languages that we selected for this. There is about 36 challenges, a mix of easy, medium, and difficult. It can take anywhere from an hour to 2 hours on average for people. It's not about who finishes first. It's by the person who maximizes the most amount of points from it. There's 3 types of things that you're going to be tasked to do. You're going to be tasked to identify a particular vulnerability within the block of code. You're going to be tasked to locate a named vulnerability, and then you're also going to be tasked to fix a vulnerable piece of code as well. Just to give you an idea of the scoring, easy points is about 100, mediums 200, 300 for hard points. There is lives lost. If if you can get the problem right the first time, you get 100% of that. If you come back for a second or third attempt, you start to get a percentage taken off. As I mentioned, you do get a first hint that is free, so I'll absolutely recommend using that just from a knowledge standpoint. But then you can also, as you start to use more hints, there will be points taken off. So you'll have to about 8:30 to complete. And then afterwards, we'll announce winners and prizes at the end of the tournament. So excited to do that. Secure Code Warrior will provide you with a first place Secure Code Warrior hoodie. And then for the second, third place winners, we'll definitely provide some t-shirts. I posted this in the Slack channel. If you haven't already signed up, you can go to this link here and register, and then you're on your way. We will keep this open for another 2 weeks. So not only you get hands on this tournament, but you also get access to the platform for another 2 weeks. So please enjoy it. Learn, and we'd love to hear your feedback on how do you like our platform and the type of training. The join code here is 1253. There is a space, then 5854. This was also in the Slack. I believe Ben has also posted this or tweeted this. So you should have the join code to get into the tournament. And then finally, I'll post this in Slack, but I would love to just get your feedback from the tournament itself. What's your thoughts of the platform? It takes less than 5 minutes, so please do fill out our short survey. So with that, good luck. I wish you the best. It's a fun, engaging tournament. Ben, I'll turn it over to you, and I know you want to go through some exercises. I'll let you run through that in the platform.
Great, and thank you so much, Dan, for providing this wonderful tool for us. So that we aren't just sitting here staring at a blank screen or watching the leaderboard for the next 2 hour or hour 48 minutes. I was going to go through some of the exercises. I was going to start in the training itself to not really give an unfair advantage towards certain challenges within the tournament. And then after 45 minutes to an hour or however long I feel like going through the pseudocode stuff, I was going to jump right into the tournament and see if I can solve any of these challenges. So without any further ado, here we go. So the stream seems to be all right, and these are the current standings. So you can see that we have. Right now, Anthony is in the lead with 520 points, and you can see where you stand among the rest of the crowd. I think we have about 20 people right now in. So I'm going to go right into training. Now I've done a few of these as practice, but this is going to be entirely live. So let's see here. This is their training platform. And I'm going through the pseudocode examples, which are not an exact, which are not a language that's available within this competition. So this will be a lot more language agnostic for those who are really strong coders. And I'm just going to go through my thought process. I'm going to walk you through the challenge itself, the task ahead, and then I'm going to walk through how I would solve it or where I think the issue is. So the first step is to locate the vulnerability. So I'm trying to follow the stream as well too and manage that. So the first thing we have to do within this pseudocode example is to locate the vulnerability. So we want to just click on whichever, there are 3 different groups, and I need to read through it and try and figure out where the issue is. Now this specifically is an injection flaw with XML, so I kind of have a slight advantage in terms of knowing what to look for. And it says that there is one vulnerable block in the source code that you need to locate. So I have to choose one of these. Now the first one is let's see, you're trying to declare the user string. So you're creating a specific username. Sorry, you're creating a specific user based on the username and password that are passed through to it. Looks like you, the username and password fields are sent to the XML and directly appended in. Okay, so that's already my the place where I would assume something could go wrong in terms of XML injection. Then there's also show usernames where you're reading XML from a file. I would assume that that would be on the back end and likely somewhat controlled. But if it's something that the end user has access to, then parsing the XML could lead to some kind of issue. But again, it's unlikely that that would be a direct source of XML injection. And then show user details. So obtain the username from the user, search the user base for the username in the database, and then display the user details. So I am going to assume that it's the first part where you are directly appending username and password, which are user-controlled objects, and that's where the vulnerability for XML injection would be introduced. Sorry, Dan, I'm going to remove you from the stream so that it only shows me and not a blank screen. And I'm trying to also help in the feed. So let me, sorry. All right, so I'm going to hit next, and hopefully that is where the issue was. Great. So I was able to correctly identify it, and now I need to figure out what the solution would be. So there's a couple of different ways. One would be to parse user input. The other one would be to not trust user input. This one also mentions remove all special characters from name and password. That is a good solution. It might not be the best one, though. There are other ways of doing it. This one looks to be using a library, so we're adding the username directly in. Not quite sure if that is the one that we're looking for. Oh, yeah, sorry. And on this screen, you can see on the left the current source code, and then on the right is the change that's going to be made. So remove all less than and greater than characters from the username and password. That's like blacklisting. So that is the wrong solution to this, and that it would prevent certain types of XML injection, but it isn't the umbrella solution that we're looking for. So this is a very, very specific vulnerability that this would resolve, and that is very easy to work around through obfuscation. So this is a solution, but it's by no means the best one. And same thing here. So we're replacing single quote, double quote with the Unicode version of it. And that is definitely not, that's the exact same problem. So it's solving the issue by addressing very, very specific exploits that would make them benign, but that isn't the actual solution. So I am going to say that it's this one, remove all special characters from username and password. All right. So that I sort of fell for the same thing. So that is a specific solution that would wrap up 3 and 4, but the correct solution was to go for the library and try and get stored procedures to prevent, to explicitly treat the user input as user input and basically untrusted. So that means that the correct solution was number 2. All right, so this is an injection flaw, specifically LDAP injection. So we have, again, we are finding a username, and we are performing a search query based on the username, which was the pass parameter. I'm not going to automatically assume that this is correct, but this looks like the vulnerable function to me, simply because the username is directly integrated with the query that's being performed. So assuming that comes from a user input, that should not be considered trusted. You should definitely not fold that user input directly into the query and then execute that query. Sorry, I'm also trying to troubleshoot some issues here. So let's see here. I'm going to try and pass this off to somebody else so that way I can continue focusing here. I do apologize for the delays and going back and forth, but I'm trying to also help people who are having issues connect. All right, and then the other part is we're obtaining the username from user, find user data, username, and save the results in user object. Yeah, I'm going to assume that the LDAP injection potential is when you are directly adding untrusted user input directly into the query. So I'm going to hit next. And I was correct. Good. So the various solutions to this are to escape characters such as wildcard and or symbols. So that is a blacklist solution, which is not what we're looking for. Execute query with the least privilege possible. That is definitely a good security practice, but I don't think that's the solution that we're looking for this specific one. And I don't see that how that would prevent LDAP injection. Execute query and save only the first 50 matches of a user. That doesn't really have anything to do with LDAP injection, so I'm going to move right along. All right, so we are escaping LDAP built-in encoding and saving an escaped username. So we are treating what was untrusted as now what was untrusted user input. We are applying in a secure method. So this solution is combining everything where we have characters that will be rendered in a benign format, and we're also executing this with the least privileges. So this is definitely the best solution, and I'm going to hit accept. Yep, so we are good. So now we have NoSQL injection. Excuse me. All right, so NoSQL injection. We are looking for a place where that might occur. So we have the statement itself where we're taking a product and we're searching it based on a function where we're returning the product name. Okay, and then we are executing the statement and saving in products. Then this is the find function being called. That's not likely to be the source for the NoSQL injection. And then find all products and save in products. That's also unlikely to be the source. So what this is doing is executing a statement based on product name, which is again user input. So this is the only one that actually takes in user input as opposed to the other two functions, which means that this is going to be the very first one is going to be the source for the NoSQL injection. All right, and that's good. So view the solutions. This is probably going to be a very, very similar solution where we are treating this as untrusted user input, which means that we want to render all special characters as in a benign format and and possibly parse the source for user input, or maybe use a special library as well as prepared statements. That's the general process that you would want to do. That doesn't necessarily apply with the NoSQL statements, but this first solution is if the statement execute without errors, then save in products. You can get syntactically correct NoSQL injection exploit, so I would assume this is not correct. We're moving very, very specific characters from the product name. That's not what you want to do to solve the solution. Again, that's like blacklisting. Remove all special characters from product name in the front end. That is good, but there are also ways to maybe push this through the back end. So while that might solve a lot of the issues, it is not a complete solution, I don't think. All right, and lastly, we want to replace this. So we are declaring that product name is a user input. So this is similar to the prepared statements of SQL injection. So I'm going to say this is the correct one. So what this would do is form a parameterized query. All right, so I'm going to back out of this now and try and do some other trainings, because I was going through OWASP A1 and A2, which is mostly injection based. So now I'm going to try the next set. So this is more sensitive data exposure and XXEs. Thanks a lot, Sean. I appreciate the support. Oh, and actually right now, I figure I can just show off the leaderboard. So I'm going to back out of this for 1 second. Right here. So wow, it looks like Ari is in the lead with 2,230 points. We got about an hour, 30 minutes to go. So keep up the good work. Okay. So again, I'm going through pseudocode, which is non-option during the tournament, but I figured this would be very, very good to demonstrate the Secure Code Warrior, how to use the tool in a way that would be more universal for everyone who is viewing this video at a later date or right now. So the vulnerability is sensitive data exposure, where you are storing passwords in plain text. So let's see here. If username exists, then you want to check for the inputted password matches the database password. log in as the user, redirect to home page and display content. Excuse me. This is the login function. It doesn't seem to be storing any data. It might have some passwords being passed in clear text, but I don't specifically see that. And that's also not quite what we're looking for with the plain text storage. So without even looking, the register function already sets off some alerts in the back of my mind. And what they're doing is obtain the username and password from the user, create user and database with the username and password. Yeah, so I'm going to assume that is the place where the password is being stored and cleared in plain text. But the last function, just to check, so it's show user data, and all you're doing is fetching data from the database. Yes, so I would say that registering at the point of registration is when the password gets stored in plain text. And correct. So now let's figure out how to resolve this issue. Now the first solution is to fix the login function. So let's see here. If the inputted password matches the fixed password, then take no action. Add pepper to the password and save in peppered password. So I'm assuming that pepper is kind of like a salt, which is a randomized token that will get added in and applied to give the hashed password a unique identifier. If, say, both of us have a password of 12345, you can look through a database of hashed passwords, and if you see that the hash password is identical to somebody else, that means that they would have the same stored password. So by applying a salt, or in this case a pepper, you are adding a randomized token at the start or end of the clear text password so that when it goes through the hashing algorithms, it will be randomized. So that way, if I have a password of 12345 and you have a password of 12345, by adding in that randomized token at the along with that clear text password, it will then appear different, or when it goes through the algorithms, it will be different between the two of us. So if the database is compromised, you wouldn't be able to know that we do in fact have the same passwords. So this looks like a pretty good solution because you are actually storing the hashed values instead of the clear text passwords, but I still want to move on and see what the other solutions entail. So this one is a base 64 encoded value. That's just looking at that, I can tell you that that is wrong. That is base 64 encoding is not a hashing algorithm. All that's doing is, like the name implies, encoding it. So that would be the same as hex encoding something, where you are converting, you are translating the characters. And it is very easy to undo that. So for example, the easiest example is ROT 13 or a Caesar cipher, where you are going through the alphabet and you're either moving it the letter A to 13 characters later, so A becomes N, or with Caesar, it's A becomes, I believe, D. So you're shifting the letters over from what they are, which obfuscates it for the human eye, but a computer is very easily able to detect and unencode that. And that's done for, say, compression or for managing the data itself, and either gain it in a way that the computer understands or gaining it in a way that is easy to transmit. But the very, very short story of that is that base 64 encoding is in no way hashing. So this solution is absolutely wrong. So calculate the MD5 hash. Yes, this is hashing. MD5s aren't necessarily the strongest. So let me see here. Calculate the MD5 value from password and save it in hash passwords. All right. So not only are MD5s, I mean, they're fine enough, but they aren't necessarily the strongest hashing algorithm. But additionally, this falls into the same situation I described before, where if two people have the same passwords, simply performing an MD5 hash will have the same hash stored in the database. And so it's very easy to, one, use a rainbow table to match that MD5 hash, and two, recognize that multiple people in the database have the same password. So this is wrong, or it's not a, this is an inadequate solution. And lastly, SHA-256. So SHA-256 hash value, that is a stronger hashing algorithm than MD5. However, you're still falling into the exact same trap where you aren't applying a salt. So if you get access to those, the database, and you just see a list of hash values, you can very easily crack them, which means that the solution is the first one. Great. So I'll do one more of these, and then I will move on to the next group. All right, so this is the exact same problem. I'm going to go ahead and skip this so that we can see something slightly different. Kind of hoping that we get to an XXE. But it really wants me to do plain text storage passwords. Okay, so that is one of the problems, is that that's one of the reasons why we didn't include pseudocode in the tournament, is that there's slightly fewer questions, simply because you can't really, doing an XXE, so XML, external entity injection, would be very, very difficult to describe via pseudocode, but it's something that you can very easily display in, say, JavaScript or Java. So I'm just going to go through this one and then probably go on to the next category. So let's see here. If the username exists, again, at login is not the point of entry, so I know that the registration is the issue. Yep. And the solution is going to most likely be not this one, not base64 encoding. MD5 was the first hash. Sorry, the first solution was MD5 hashing, which already shows weaknesses. So we want to, again, apply a salt, or in this case, a pepper, which is a randomized token that will make a hash value unique. All right, and if, well, let's see what the next question is. Okay, so I finished this group of sensitive data exposure. Insufficient layer protection. So I believe this is the next group, but I just want to verify. Yeah. So I'm going to work on missing function level access control, which is a very big issue when you're dealing with microservices. So this is a very, very common finding that I have on a pretty regular basis, where once you're authenticated, you might have full access to all the microservices, even if some of those microservices are, say, administrative controls. So this is a very, very critical issue in terms of securing an application. So let's see here. The very first thing is login user. There isn't really much in there that's associated with function level access control. There are tons of security vulnerabilities that you have to deal with within the login step. Right off the top of my head, SQL injection, but function level access control, once you are logging in, you aren't really, the login function is not really a source for missing function level access control. Again, missing function level access control might be if you are trying to, say, skip login. So I'm at a banking site and I'm trying to, I don't know, view a user's balance or transfer money within a user's from one account to another, and I'm trying to do that without actually authenticating. So that would be trying to circumvent the login step, which means that the source for the vulnerability would be the check to see whether or not you are a user admin. And funnily enough, that is the exact scenario I described when I was just introducing this issue, where a lot of times the check for whether or not you are a user admin is missing. So I'm going to assume that I believe that this is the source for the function level access control. And I'm correct. So let's look at the solution. So the problem was if the role, so the problem itself was if the role is a user or admin, which means that any valid user, once you have authenticated, once you get a session token, you can view the admin page. So the very first solution looks to be the resolution where it's actually checking to see if you are an administrator only and not just a user. I think the better solution, or the intended solution for the original pseudocode, was if the role is both a user and admin. So if they're maybe authenticated and they're an administrator. But again, a lot of times you can't be an administrator without also being an authenticated user. So that is unnecessary and opens you up to security vulnerabilities such as this one. So the other solution is a lot more complex. This just looks wrong to me, where there is now no check whatsoever for show the admin page. But let's see what the request itself does. So we have create an admin pages list, create logged in pages list. So you're creating various lists of users, and so let's see here. That's a little better. So if the current user's role is an admin and they are requesting access to an admin pages list, then display the requested page. Okay, so that's pretty good logic. If the role in the session exists and the requested page is in the logged in pages, then display the requested page. So if they're administrator, get them to the and they request the administrator's page, send them to that page. If the role in the session exists and the requested page is logged in, so if they are authenticated and are requesting access to an authenticated page, grant them access to that. That logic is good. That helps prevent you from being unauthenticated and being able to access a specific page. Otherwise, if you're requesting a page in the no login page, display the requested page. So if you're not authenticated, then display the requested page. Yeah, that's sound logic. There are lots of static content pages that you should be able to access, primarily the login page, where you don't necessarily need to authenticate. And then lastly, there's an error page. Yeah, so if the page you're requesting cannot be found, display an error and return them back to the home page. That is a very, very good check. So right now, this is a much stronger solution than the first one. This looks very, very similar to the first one. So let me try and figure out this looks very similar to the second one. So let me try and figure out what the slight difference is. So the difference is the logic in the first one. So the second one is correct, where if the role is an administrator and you're requesting a page in the administrator pages list, display that page. The third solution, if the role in session exists and the requested page is an admin pages list, then display the requested page. That's the wrong logic. So that is saying if you have a session open, so if you have authenticated and you're requesting an admin page, then display that requested page. So any user will be able to view the administrator page, which is the exact opposite of what you want to happen. So this is more robust, but it's not the correct solution. And lastly, this is the wrong solution. So if you are a user, then display the control panel, which is the admin page. That's definitely wrong. So it's between number 1, where you're making sure that you are at least an administrator before displaying the control panel. So I do like how succinct that is. I do like how succinct the first solution is, but I do like that this one has a lot more error handling. So I'm going to say this is the correct answer. Also because it not only checks that you're, it doesn't automatically grant you access to the administrator control. It checks that your session is an administrator and that you're requesting an admin page. So I do like the more robust logic for this one. So I'm going to say this is the correct answer. Yep, and we are correct. All right, so access control is this vulnerability. Using input from an untrusted source. Simple answer, don't. But let's see where the problem comes in for access control. So let's see here. So login, if the username and you're obtaining the username and password from the user. If the username and password match, so if they match that given user, so if Ben Pick is logging in, his password's 123, that matches with what's in the database. That is technically an untrusted source. And that is a good means of bypassing, say, a login screen. I want to keep going through just to make sure that that is the solution to this. Then we have show absences. So if the session exists, get the user ID from the cookie, fetch the absences for the user ID from the database, and then display them. So this is not going from an untrusted source. Actually, sorry. So the cookie is in the control of the end user. And you would be getting the user ID from the cookie. That I would consider to be untrusted. But the rest of it is not. So fetching absences from the database, from a functional standpoint, you want to assume that your database is trusted. From an actual standpoint, I tend to assume that databases aren't trusted, but that's way beyond what this is trying to train us for. So for this purpose, I'm going to assume that the database is trusted, which means that fetching a specific value from the database is assumed to be trusted, and then display that. So right now, I don't trust the cookie value, and I don't trust the username and passwords. However, the last one. So given an absence, so you can create an absence based on date and reason. And we are inserting an absence in the database with a date and reason. Okay. So this one's actually kind of tricky because all 3 of these could potentially be untrusted sources. So for example, you are logging in a user and you are applying a username and password to match. The only difference and the only way to distinguish between these 3 in this specific example is that the user function is taking in no parameters and the absences is taking in no parameters. So I'm assuming that this is somewhere closer towards the back end or not directly interacting with user input. So this might be some kind of back-end function because it seems like the cookie is not coming directly from the user. So this might be the cookie. This might be the cookie that the server itself is tracking, and it's using that information to obtain the user ID. And so where it says obtain username and password from the user, that might be some external function. And then right here, it already has the username and password to match. So I'm going to say that the only place that takes in input would be the date and particularly the reason. So I'm going to say that those are untrusted because those are the only sources of input for this, as far as I can read. Nope. Okay, so I was wrong. Let's see here. I'm going to retry. So if I take it at its word, then I would say that the username and password are untrusted because those are coming directly from the user. So I think I talked myself out of the correct answer the first time around. No, okay. This isn't good. So it looks like, well, it looks like the cookie is in the control of the end user, and that is being used to obtain the user ID. So I was on the completely wrong mindset in how to solve this. Yep. All right. So this is all just a great learning experience. So how do we solve this? Well, you don't trust a cookie coming from a user. So the solution itself is to save the user ID in the session. Redirect the user to show absences with user ID in URL. I don't like that part of it. And then get the user ID from the session. So I do agree that we should be getting the user ID from the session. I disagree that the user ID should be passed in the URL. So let me see if there's a different solution that addresses that still pulls the user ID from the session without passing the user ID in the URL. Let's see, you're redirecting the user again from based on the URL, and you're getting the user ID from the URL. The URL is absolutely in control of the end user, so this would not solve the problem. Save the user ID as a local variable. No, that's the completely wrong approach. So let's see if the fourth one has it. Save the user ID in a hidden field. Hidden fields are also in the control of end users, so we're going back to solution one. Yeah, so I 100% agree that the saving the user ID in session is good. I don't like that we're still passing the user ID in the URL, but that this is still the best answer, in my opinion. And it's correct. Cool. Sorry, so I'm back in here with access control, so I might want to move on to the next one since I've already done this. Yeah, I've done this exact example, done this one, and I've done this one. Yeah, so I'm going to go back out here, go back to mission control, and I will go to the last example, and when I solve these, I'm going to officially join in the tournament. So, you know, leaders beware, because even with an hour and a half delay, we'll see how many points I can rack up. All right. So we have an injection flaw, which is deserialization of untrusted data. Now we are creating a user creating a user based on the username and password. And then we are serializing the user object and saving it as a serialized user. Then we are later fetching the file with name, username, and deserializing the user object. Ooh. Oh, sorry. So I need to read the full pseudocode. Obtain username and password from user. So this is definitely untrusted. You are serializing untrusted data. And let's see if that's correct. Nope. All right. I was wrong. Because you are in fact, oh, yeah, sorry. The question was talking about deserializing untrusted data. And here, here we're fetching a file with name username, and the username is the pass parameter, which then got deserialized. So that would be the correct answer. Yep. And let's see what the solution is. Use a secure deserializing library. That is a very strong solution. I really firmly believe that this would be the best answer, but let's keep going to figure out that's correct. Blacklisting, I know that answer is wrong. Blacklisting should never be your first solution. It can maybe augment something, but it shouldn't be blacklist all classes for deserialization. That is exceptionally difficult. The creating a list of, say, invalid characters one at a time is always going to be a losing battle. Just because of the way that obfuscation occurs or the ever-changing libraries or classes. I would never recommend solution 2 or 3. So then we are using a secure deserializing library to deserialize the user object. If this occurs without error, oh, this is good. So if this occurs without errors, then display the user, otherwise log the error. So let's see what the difference between solution 1 and solution 4 is. So whitelist whitelist classes for deserializing. Yeah, so I'm going to say that this one is possibly better because you are choosing the specific library used to deserialize as opposed to just saying that you can use any, as opposed to say including, 3 libraries that you can use for deserialization. I think this is a more specific solution. And I would trust the developers to know the exact library to use. So I would say this is a better solution than 1, and 2 and 3 should not be the solutions. Nope. All right, so it looks like solution 1 was the correct one. There we go. Yeah. So unfortunately with pseudocode, there's only a limited, it is very difficult to show the other OWASP. Here, let me go back to mission control to explain the problem. So I was in OWASP A8 through A10. It is very difficult to show within pseudocode insufficient logging and monitoring or using components with known vulnerabilities. Doing that well within pseudocode is definitely difficult to do. So I have walked through as many of these as I can, and I'm going to start going through some of the tournament problems. So let's see how well this goes. So I have a tendency towards Java. So let's see here. I'll do JSP. And I can only choose one, right? Yeah. So I'm going to do JSP. Hopefully this goes over well. and accept. Okay. So I need to identify the type of vulnerability present in the code and select from the objects below. So the vulnerable files and lines of code have been marked with the X's. All right, so let's start off very, very slow, do the exact same process. So the problem is, or the vulnerability is within this entity manager. And we are trying to save delivery details. And it looks like this delivery details is primarily vulnerable. So we have here is a select statement. That automatically, I'm thinking, well, I was thinking injection, but let's see here. So we have a query string of selecting from the database where the order ID is this past parameter of order ID. Then we are directly executing the query, which is bad. Although we are defining that the order ID is untrusted, or rather is user input. So this is kind of this appears to be creating a parameterized query. And then we're committing that. Okay, so I think that looked okay to me. All right, now the problem here is, delivery address. All right, so this looks much more pressing for an issue, where we are taking the house number and directly displaying it within, okay, this cross-site scripting. This is DOM-based cross-site scripting as opposed to stored cross-site scripting. Let me think. All right, so where are we getting order details from? So we're getting it from an XML. We're escaping from. Yeah, I'm still going to say this is DOM-based cross-site scripting. All right, looks like it was stored. Let me try and figure out why I was thinking this wrong. Oh, because it's pulling directly from the database, and this is not. Yeah, and this is not user input. All right. Cool. Okay, I am going to start with a level 1 problem. And if you want to shout out that I'm doing something wrong, go right ahead. Not that anybody is doing that at the moment, but if you want to give me suggestions or pointers or anything like that, please feel free to do so in the chat window and or YouTube channel. I have both of them up. So if you want, we can try and make this a little bit more collaborative instead of just me talking into a screen. So let's see here. So we are identifying the type of vulnerability present in the code. All right, so we have the file upload service and the file upload servlet are the two problems, are the two problem files. The only issue here is that we are reading the object, so I think the service itself is where the vulnerability comes in. There we go. So that makes this a little bit easier to see. All right, so we have the file upload service implementation. We're logging everything. This okay. So we have the document build factory. Already, my own personal alarms are going off for XML parsing vulnerabilities, so that would be XXEs, but that wasn't an option. So let me actually read and see what's going on in here. By the way, we have just under an hour for the remaining of the tournament. That will end in 54 minutes. So try and, if you're making great progress, keep up the good work, and we will. In the Slack channel, we have the leaders. As of 6 minutes ago, the person in first place had 5,830 points. So congratulations, that is that is great work. I will definitely not be able to go up that high, but we'll see how many of these I can work through in between now and the end of the challenge tournament. So anyways, we are building the XML document, and we are including information about the employee itself, or themselves. So we have their ID, their name, their gender, their age, and we are getting these values from the XML that was being read. Okay, so this is definitely untrusted user input that's being parsed from an XML document. Yeah, I don't trust that. I don't trust that. I don't trust that user input. So let's keep going in. And then it looks like this code is then writing that employee object. So, and reading it. All right. So it is, this application is taking employee data from an XML, from an uploaded XML document. It is parsing that XML and then creating employee objects based on those, based on the input that's being parsed, and then lastly, reading those various objects. And it looks like when you are reading the employee objects, that's where the vulnerability becomes triggered. So this is definitely some kind of injection flaw. Let's see what our options are. Side channel attack, I don't think so. This seems more like an injection flaw than anything else. I do not see information exposure. It wasn't really, although, yeah, this could potentially be information exposure, simply because if you're reading an employee object and that employee object is invalid, then you could be displaying the stack trace to screen. Yeah, that could potentially be an issue. I would be less concerned about that than I am about the directly reading and writing of the employee objects from an XML document. And then untrusted transport of credentials. Well, I didn't really see any credentials being passed in here. So I am going to say that this is an injection flaw. Also, sorry, URL caching, I didn't really see any. This was not taking in any URL inputs that I saw. Now, if it were at the point of upload, there are some interesting flaws that you can look for, where you can try and maybe rewrite files within the application server. So if you are changing, say, the uploaded file's file name, that would actually be a really good vulnerability. Or if you are, yeah, so that would be a good vulnerability, but that doesn't really apply here. And I don't see URL caching as a possibility. So I'm going to say that this reading in from an XML file of an employee and then storing that as a binary file and then reading that object, I would say that has the potential for one, reading untrusted data, and then two, deserialization. So I will say that this is an injection flaw. Yep, and we are correct. So I am on the scoreboard. Now the solution. Well, don't upload files. No. Let's see here. So the solution comes from this file that it's adding called blacklist object. I'm going to skim right over this, but like I keep saying, blacklisting is never the adequate solution. So you have a list of characters that you will not allow within the uploaded XML document. This is an outright wrong solution. So this, I'm going to just move on to the next one. And what we are doing is trying to resolve the issue within the employee object itself. So what it's doing is, okay. So it's trying to see if the class within the, cool. So at the moment, the third place is changing up by the minute. So good job. You guys are really making this into a race. So congratulations. But this solution itself, we are trying to verify that the input class matches the employee class. So that seems like a good solution. And there are no differences in this file. So all this comes down to is verifying essentially that the schema within the uploaded XML, after being read, matches what you're expecting within the employee object. That seems like a pretty good solution, but let's keep going and see if there's a better one. Okay, so we are using the whitelist object input stream. Not much of a difference here, except that you are applying this whitelisted object input stream. And what we are trying to do is, okay. So we are, so we're declaring a protected class, and we are trying to, set the employee class as the whitelist value. Okay. This seems good to me. Yeah, this definitely isn't a really good solution. So read unshared. The only difference there is this unshared function call, which I don't see anywhere else. Yeah, this is not adequate. All right, so then I'm going to say that creating this whitelist object and defining the employee class as the whitelist object seems to be the correct solution to me. And let's see here. Yeah, this looks pretty good. So I'm just going to say this looks good enough. Yep, cool. So the correct logic for this one is that the solution uses its own object input stream to securely deserialize the untrusted data. So before, solution one, I think, was trying to like cast the employee class in a certain way. So that was not the best solution. All right. And again, this is a good solution if the list of expected classes is small and can easily be identified. Yeah. Whitelisting really only applies when you can correctly identify and apply exactly what you want your application inputs to be. If they can be a massive list, then, well, you probably need to redesign it because there's some likely going, in my opinion, there will likely be some other issues there in terms of the application's design. But that's just, my 2 cents. So then we have, moving right along, the next one. All right. So we have, again, the file upload. And so the problem here is these 3 lines where we have an object input stream where we're obtaining from a binary, an employee binary file. Then we are declaring the employee object, and then we're closing the object. I'm sorry, then we're declaring the employee, casting the employee object, and then reading the object from that binary file. Now the binary file itself is being written from being written right here. We are writing the various employee objects, and they are coming from this XML file. So this is very, very similar logic to what I was looking at before, only the vulnerability is slightly different. Okay. So my natural inclination is to say it's the exact same issue, but I feel like that's wrong. I don't think it will be local file inclusion. Particularly because because this is directly reaching out to the employee binary file. Oh. Okay. So this actually could be the local file inclusion because you are directly reaching out to the employee.binary. Typically when I see something like this, I think I would be concerned if you had control over the file that's being extracted. So for instance, if you are looking at an application and within the URL, it's going to a specific location to retrieve a PDF. Well, if you instead change that from, 3.pdf to 1.pdf, then you might be able to view somebody else's file. That's typically what I think of when I see something like this. So I don't, while employee.binary is a local file, I don't really see that as the issue here, unless I'm missing something. Yeah, so these 3 lines are the only 3 lines that are the vulnerability. So it wants us to focus here, which means I don't. Oh, cool. And we have a posting of tonight's presentation in the Slack channel. I definitely don't think it's password enumeration, simply because, well, there's no passwords being read in or passwords being applied to view this object. Information exposure, it could be. So doing this might reveal all employees within that binary file. Or again, I might be just reading into this too much, and we should assume that there is some kind of vulnerability already in the employee binary, at which point reading the object would lead to a deserialization of untrusted data. Let me go back up to here. String file path. All right, I'm just going to try and focus on these 3 lines without digging too much in the code, because I think that might lead me down the wrong path where I convince myself that a wrong answer is correct. I'm just going to say deserialization of untrusted data. Again, it's definitely not password enumeration. I don't see any place where we are directly controlling the file and path. So I don't think it is local file inclusion. Yeah, I'm leaning more towards deserialization of untrusted data than I am information exposure. And I'm correct. Cool. Yeah. So again, I think I am reading a little bit too much into these, so I probably should just go with my first instincts. Because it's definitely trying to narrow your focus by showing you just 3 lines of, trying to show you the 3 lines of code to look at. And I think I'm trying to take in way too much and kind of skew my opinions of what the problem actually is. All right. So the first solution is to set up a direct object input stream and remove this input stream and set up some kind of regular expression for the blacklisting and set up some kind of regular expression for whitelisting. So you want to ensure that your employee is within a specific group. I don't really like this solution at all. Yeah. You are moving from the employee object input stream to the broader object input stream, and I think that would be harder to secure. So I don't like that one. Let's see here, serial killer. Okay. Oh, I see what this is doing. All right, so this is trying to prevent a very specific vulnerability. So when serializing, deserializing data, one of the very common exploits from a couple years ago was called Why So Serial. And that is very, very effective when reading in data from, say, an XML, or in this case, a bean shell. Now, what this does is explicitly prevent certain Why So Serial payloads by looking for regular expressions of those exploits. This is a very, very specific solution to a general problem. And again, blacklisting is never really the correct answer. So I'm going to move on to the next one. So again, we have yeah. So this is another instance of serial killer, and it's much less robust. Well, for starters, this one is like solution 2, except that it doesn't apply the whitelist. So I am probably going to go with solution 2. Yeah. But again, let me work backwards. So this does include the whitelist expression, which is good. And solution 2 also does that, but also, so it includes the whitelist regular expression, so it ensures that you are applying the employee binary in there, and it's also checking for specific issues. That's not the worst solution. That's actually pretty good. Find serial killer file input stream. So this one creates it, but I don't actually see where it calls it. Unless I'm missing something here. Okay. So solution 2 looks like the best solution to me. Moving that class, bring this in. Okay, what was 3 again? Okay. So what's the difference between this one and solution 2? Okay, so I don't think the difference is right here, so it's probably in... Oh, right. So the difference between solution 2 and solution 1 is solution 2 and solution 4 is that solution 4 doesn't have the regular expression for the whitelisting. So solution 2 is definitely the best answer of these. Because while it does rely on blacklisting, which I don't like, it also does properly implement whitelisting. So it's looking explicitly for this employee. And yeah, I mean, that's fine. So long as you aren't only relying on blacklisting and you have a robust, a good solution, in this case, line 35 right here, that is a good practice. So you can prevent specific vulnerabilities that you know you will be susceptible for, but also ones that you wouldn't know to look for. And that's what you're doing with whitelisting. You're explicitly looking for the employee within the binary. You're explicitly looking for the input data to be in a specific form while also preventing known bad things. So yeah, I'm going to say this one. Nope. All right, I was wrong. Okay. So the application uses a secure deserialization library for Java called Serial Killer. This library allows whitelisting and blacklisting classes. However, the library is configured incorrectly. Oh, I see. So the serial killer configuration sets profiling to true. Oh, that's where I messed up. All right, I'm going to retry that. So it's the same basic theory. The big problem of where I messed up is that line right there. Missed it. Because right here it's set to true. All right. Which means that solution 1 is the correct answer. Because they're both functionally the same, but this profiling sets it to blocking mode, which is much more valuable and useful than having the blacklist in place. Okay, that's fair. I missed that. Well, I'm way off tonight. All right, let's see here. Oh yeah, so the leaderboard right now will black out in about 7 minutes. As I kind of fumble around a little bit here. Oh, right. I jumped too soon to the solution. Okay, so the problem with solution 1 was this right here, was that it was using the object input stream, so it never actually applied the serial killer. I jumped too quickly to the solution. So number 3 was the correct answer. Yeah. Because it applies the serial killer function. And if you go in here, it has profiling set to false, which I missed before, why this answer is better than solution 2. And it still has the whitelisting. So let's go through all these again. So number 4 is definitely wrong because it has no whitelisting applied, even though it does correctly apply blocking mode. Solution 2 has everything right except for line 7 where profiling is set to true, which means that blocking mode is not applied, and blocking mode was applied in solution 1, except that function was never called because you aren't actually referencing the serial killer configuration right here. Oh, all right. Well, it looks like we aren't doing any blackout for 20 minutes, so you will know who is in the lead right up until the last minute. And it's definitely not going to be me because I am trailing very far behind in terms of points. So again, this one applies serial killer function and also applies the configuration file added here, which means I got it. All right, let's see. Oh, don't think I'm doing too great there. Okay. So authentication, good. Here's the lines. So we're applying a filter from the request to find the request and the response, URI and session. Okay. Excuse me. So we are validating the URI that's coming in. So if the URI contains, I'm going to assume that this is some kind of URI injection. Wow. So if the URI that's coming in from the request contains a very, very specific list and does not contain font awesome, then you actually apply this filter. Wow. Okay. Sorry. So it's checking to make sure that the URI contains certain values and does not contain something, but the logic itself is broken there because this part will be evaluated together. Yeah. So this logic would be very easy to bypass because the and or logic is broken. And if the and or logic is broken, then you could actually circumvent this login function right here. So I'm going to say this is improper authentication. Yep, and I was correct. Okay, so specifically the user docs is unprotected. Yeah, so this last function right there. All right. So the first solution, don't actually see here. So the first solution is to just remove the tailing end of that of user docs. So we aren't actually applying, we aren't adding that into the check. Don't like that solution. Don't think that's sufficient enough. This is the so this is where they differ. Okay. So the original, or let me just verify this, because I want to see if all of the solutions on this within this class just remove this from the function call no. So these are quite different. So I'll have to go through them one by one. All right. So within the API content itself, we're looking at the session. We are getting the current user from the JSession user. Okay, so that's the cookie JSession user. All right. Wow. So we're removing all of the validation logic for checking users. Okay. And we're adding bad credentials. All right. Huh. Here again. Wow. All right. This is a bit complicated. I don't necessarily. Okay. Well, this is definitely just wrong. Yeah. Well, this one's 100% wrong. I don't really need to go through much more of the logic in here. Hard coding a secret value is always going to be wrong. So we don't even need to really focus on the rest of the logic in this. So we have is if, so we're setting the current user based on the JSession user attribute. Now, if the current user is null, then send them to an error. Otherwise, allow them to view a URL document that they're requesting. So I see this as allowing any valid user access to, so long as they're a current use, so long as they have a current user, which means any authenticated user, they will be able to reach that URL document. So I don't think this is the correct answer. Let's see two. Okay. So we're still getting the user. We're checking to see whether or not that user is an API partner. That's good. And then we're letting them view that. Okay. Pretty decent control. And we're also just removing the user.endpoint endpoint. So now you're only able to go to very, very certain endpoint directories without authentication. Otherwise, you need to go in and have a valid session, which is fine. So there are static files which you should be able to access without authentication, which makes sense. So let's see what solution one does. So let's make sure that you're an API partner. So for instance, you might have higher privileges. And okay. I don't like how much this is removing in terms of validating all the various fields. I just want to go ahead and say 2 then. All right. Just making sure that you are an API partner. If you're not, then it sends you to an error page. And if you are, it allows you to access the documents. I'm going to say this looks good. And I'm wrong. All right, so the problem is that access is controlled to role partner, which ensures that not all users can access the documentation. Instead, only partners can. It then redirects the user to an unprotected session, unprotected resource. Okay. So all right. So let me see where my logic is wrong. Oh, missed this. I feel like solution 1 was kind of solving the wrong problem. Oh yeah, definitely don't like solution 3. And solution 4, if you all right, I don't like solutions 3 or 4, so guess we'll just go with solution 1. Yeah. Cool. All right, so now only the partner API developers using their own private credentials. Cool. Sorry. So the new problem here is get encrypt password. Well, if you are on the Slack channel, it's getting interesting over there. So I'm going to go back to focusing on this. So let's see here, string encrypted password. We have string get encrypted password where we are just returning the value password when passed in a salt and string password. This doesn't appear to be doing anything. That is definitely a problem. So based on the function calls, I would assume that the get encrypt password is encrypting the password based on the salt, but all you're doing is returning the password, which means that this is not doing anything. I don't see, I don't see anywhere else that the cryptography is being applied. So I'm just going to say this is weak algorithm use, and that the encrypt password function, which is intended to encrypt the password using a salt, is just returning the password. Yeah. This is just wrong. Yep. Cool. Yep. So the use of weak custom algorithm without a key is a problem, or saving the password as plain text does not provide protection against attacks in the case of breach. Yeah. So right here, again, there is, you're not encrypting the password based on what I'm reading. So let's fix that. All right. And it looks like the person in first place has 9,130 points, and we have about 8 minutes to go. So I'll probably solve one or two more. Well, try and solve this one, and then I will probably solve one more, and then just do a little countdown of going back to leaderboard. So let's see what the solutions are. We have password plus simple salt. So I don't like this one at all because you have a static salt value, which means that when you're coming to the exact same problem before, way back when, where if you have two passwords with the same salt, you're not actually encrypting anything different. So by applying the same salt to two of the same password, so my password is 12345, your password is 12345. If we apply the same salt to it and then go through the hashing algorithm, the end result will still be the same. The point is that a salt is a unique value, and this salt that's being passed was not actually used. So solution 1 is wrong. Solution 2, so generate password is null. You have a message. You have a message digest. You apply a salt. And generate password. Okay, this. Yeah. So you're updating based on a salt, and then you're generating the new function. Yeah, this seems, in terms of general flow, that looks all right. Yeah, returning just a clear text password and a salt is not the right solution. And base 64 is encoding, not encrypting. This one is 100% wrong. This is not. This still isn't encrypting anything. This is encrypting things, but it's applying the static salt value. It's also kind of doing its own encryption algorithm, which I don't like at all. And so we have solution 2. And I'm going to see if I can solve one of these really, really quickly. So cool. So it looks like I finished all of level 1. So I'm going to try and do a level 2 in 5 minutes. Let's see what I can do. All right. Really, really quickly now. So we have registration of a user based on username and password. All right, and the sign up process. Okay, so string response, the registration. Yep, so there are 5 minutes left, and then we will close this down. Oh, prepared statement. Okay. Yeah. So the problem is that you are plain text storing your password. You are doing everything pretty well. Prepared statement, you are writing to the database untrusted users in a parameterized query, which is good. The problem is that you are directly storing the password. So I'm going to say that the problem is plain text storage of passwords. Cool. And the solution would be to apply user manager. Okay, so we are applying a hash value, which is good. But again, I don't see assault. Still don't see assault. So I don't think that's the best answer. Oh, nice. And we have the final countdown going on the Slack channel. So no pressure. In fact, if you want, I can actually play this. I don't know if you'll be able to hear it, but got the final countdown. Oh, no, not going to be able to hear it. All right, so all right, we have create hash based on the password. And this does apply assault. All right, so I do like this one much better. Let's see if 3 and 4 work. So we have the user manager. It's the only difference. This doesn't. Oh, there we go. Okay. Des is very weak. You're applying a static value. Sorry. Yeah. This is not a hash value. This is encryption, which means that you then need to do key management and all types of other problems here. So this is definitely not good. So definitely not 3, among other issues. For passwords, hashing it tends to be better. In fact, easier to manage. And I definitely I haven't seen, if you are going to encrypt your passwords, definitely don't use DES. And so let's see here. This one is basics for encoding. Okay, so that's wrong. So the correct answer is this one, solution 2. Cool. And we are down to the last minute, so I'm going to stop. Let's see. I didn't break the 1,000 mark. But you can see that we have 28 seconds left. So we will, you know what? Let's see if I can do one in 20 seconds. Store cross-site scripting. Oh, sorry. You were directly, for that last one, you were directly storing values for username and inserting them into the database. So that one lit up for me for stored cross-site scripting. I didn't really get a chance to do full analysis, but that was my first inclination. So wow, I am going to bring back up the stream. So let's see. Hey, Dan, are you there?
Yes, I am.
Cool.
Very close finish that we had there at the end. It was getting crazy. I'd say the last 45 minutes in the tournament here, and big congratulations to Philip Marlowe finishing up in first with 9,430 points. Jumping to the lead there, and then we've got second place. And I hate to say it, butcher the name, but it's Zhengxiao Shi finished up in second place with 8,760 points, and that's only 10 points more than our third place Ari Kalfas. So it was really close there, and it was neck to neck. And I'd say in the last 20 minutes, even into first place. But really, congrats to everybody that participated tonight. Ben, I thought you did a great job just walking through problems, listening, going through some of these challenges, and I just hope everybody took something away from this. That this is something that was both fun and entertaining, but it's also a learning experience, and hopefully that what you learn in this you can take and recreate some of the knowledge and utilize in your own secure coding practices. So the first place winner is going to get a Secure Code Warrior hoodie. So send me a private message in Slack, or you can send me an email at dlewin, that's LEWIN, at securecodewarrior.com, and I will get out to you a hoodie to you. And then for the second, third place winners, congrats again. You'll get a Secure Code Warrior t-shirt. But again, Ben, it was a pleasure. I really appreciate the opportunity to let me present Secure Code Warrior to your chapter.
Sure. And thank you so much. Again, I really, really do appreciate this. This was a really cool tool. You saw that some of my coding skills are there. Some of them are a little off. But yeah, it was great just to have fun practicing. So congratulations, and thank you everybody who participated. Just one last note, we will have our next virtual meetup on Thursday the 21st. That's when it's scheduled for, so keep a lookout for that. And again, I really, really do want to thank Dan and Secure Code Warrior. I hope you all had a great night. I hope you all learned something, and I'll see you next time. Take care.